This is R.D. Sharma Solution Class 12, Chapter 9, Continuity. Exercise is a 9.1. If fx is this, x is not equal to 0. If fx is continuous at x equals 0, then find f0. So f0, see, first is limit x tends to 0. Then we apply limit x tends to 0 and we can see that sin x by x is 1. Limit x tends to 0. So the best way is to divide the numerator and denominator by x. So this is the fx or function which we are talking about. 2x plus 3 sin x divided by 3x plus 2 sin x. And since we can divide the numerator and denominator by x, the x gets eliminated and we'll get sin x by x. And we know that limit x tends to 0, sin theta by theta or sin x by x is 1. So we will divide the numerator and denominator by x. So I'll show it to you here only. Let's divide by x, divide by x, divide by x. So what do we get? X gets cancelled. 2 plus 3 sin x by x here. Here we have 3 plus 2, again sin x by x. Now we can apply the limit here. Limit x tends to 0. Let's apply it here. Limit x tends to 0. So limit x tends to 0, limit x tends to 0 here. This sin x by x is going to be 1. This sin x by x is going to be 1. What do we get? 2 plus 3 into 1, 3. Here 3 plus 2 into 1 is 2. So 5 divided by 5, which is going to be 1, and that is equal to your f0. This is your answer. Now this kind of question we have done, find the value of k for which fx, because we have to, it's already given that it is continuous at x equals 0. When we have x equals 0, it's k. If you go back side or front side, it will be 1 minus cos 4x by 8x square. And we know that there is a relationship 1 minus cos 2 theta is 2 sin square theta. So whatever is there with cos divided by 2. So you have 2 sin square. This is 4x by 2 is 2x. Then this is 8x square. So you can write it as 2 into 4x square. Now 2 you can cancel, and this is sin 2x divided by 2x whole squared. So this is whole squared, and now you can apply the limit. Limit is x tends to 0, and since sin theta by theta, as we have seen in various questions now, that limit x tends to 0 for sin theta by theta is 1. So this is 1 square, and you have to equate it with what? The value of function at x equals 0, which is k. So k equals 1. Now the answer I showed you, this is how you are going to write exactly while answering in your exam or in your classwork. Now almost same kind of question here. So let us do it quickly. We have to equate it by 8. Okay. Now, rather than going for left hand limit or right hand limit, we can see that we can devise this or formulate this in a way where we can easily solve it using the limit. So this is 2 sin square, 1 minus cos 2ks is 2 sin square. Whatever is this 2ks or theta, you have to divide it by 2. 2 sin square kx, and this is x square. Now just in k square, I'm having it here or introducing in the denominator, so you have to write in the numerator as well. So 2k square I am bringing in front. This is sin kx by kx whole square. So sin theta by theta, limit theta tends to 0. This is going to be 1. Okay. So what do you get? You have 2k square. This is twice of k square. And what is 2k square? It is given in the question that it is equal to 8. So limit x tends to 0. Fx is equal to f0, that is the value of the function at 0, which is 8 in this case. So 2k square is 8. K square is 8 by 2, which is 4. So k is plus minus 2. This is the answer. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. X equals 1, k. X not equal to 1, this one. Okay. So there are ways you can do it. First, I'll tell you a way in which k will come as a different number. So let us start with the way which is very normal. X minus 1, 10 pi x by 2. And we can just apply the limit here. And we know that when we apply the limit, x tends to 1. And we can change this x minus 1. This we are going to do in the actual solution also. So x minus y you have to put as, say, y or any variable you can take. So x will become 1 plus y. So in place of x minus 1, write y. And 10 pi. In place of x, write y plus 1. This goes here. So y plus 1 it will be. 1 plus y divided by 2. Okay. Now limit will change because it is x minus 1 equals 0. So x tends to 1. So y will tending to 1 minus 1, that is 0. So limit y tends to 0 you have. And we know that this tan theta by theta, limit theta tends to 0 is going to be 1. We already seen that. But are we going to get the exact result? Let's see what do we get. So we have y, and this is 10 pi 1 plus y by 2. Now divide the denominator by 1 plus y by 2 and multiply by 1 plus y into pi by 2. That is, you have to include that also. Now why we have done this? Limit y tends to 0 here. So this whole term tan theta by theta is going to be equal to 1. So what do you get? When you apply the limit, you will get y and you have pi 1 plus y by 2. Now the limit is existing. If you apply limit y tends to 0, what do you get? Just apply y tends to 0 or y equals 0. You will get whole as 0. So what you will do is, you will say, oh, k is equal to 0 because you are going to equate it with fx. And what is x at fx? f1. So f1 is going to be k. Okay. Now the scenario here is, you will get k as 0. Now the exact solution is not like that. So this is the only way which everyone will try, because k is 0 in this kind of solution. That is wrong. So I'll give you the actual way how it needs to be done. See here, this x minus 1 equals y. You have to take this x minus 1 equals y. That is going to remain same. That won't change. So this x will become y plus 1. Those steps are will go on like that. So limit y tends to 0 and y tan pi. So pi, this is 1 y plus 1 by 2. Now you see here, we will use this pi by 2. So I am writing this 10 as 10 pi y by 2 plus pi by 2. So it is 10 pi by 2 plus theta. And what is tan 90 plus theta? It's cot theta. Tan 90 plus theta is going to be minus cot theta. So you have minus cot pi y by 2. Okay. You have a negative because tan 90 plus theta is minus cot theta. Cot is what? Cos by sine. So cos pi by y and sine pi by y, pi y by 2. Okay. Now let us, we know that cos pi y by 2, if you apply the limit at y equals 0, we'll get a 1. But limit sine theta by theta is 1. So you have to, cos 0 is 1. Sine pi y by 2, we can change it to sine pi y by 2 by pi y by 2. Cot theta, cot 0 is 1. So we can apply the limit in the numerator. For denominator, we will divide it by pi y by 2, multiply by pi y by 2. This is all going in the denominator. So now we apply the limit. Limit theta, this y tends to 0, this is going to be 1, and this also is going to be 1 because it is cos 0 is 1. Okay, so what is remaining? Minus y divided by pi y by 2. Y gets cancelled and 2 goes up, so it is going to be minus 2 by pi. So this is going to be equal to k. So this is the actual way in which this question needs to be done, not in the way the solution I just gave you few seconds earlier. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. So cos x we have, k into x square minus 2x we have, and we can apply the limit also, but without even applying the limit we can even solve this. So let us see how we are going to do this. Because x equals 0, if x is less than 0, then we have to use k into x square minus 2x, it is less than 0. When it is greater than 0, we apply what? It's cos x. And we will apply 0 minus h and 0 plus h in the left hand side and right hand side respectively. First, we have to equate it. Now, whether it is having a continuity or not, let us see. LHL is, we are putting x as 0 minus h. RHL, we are placing it as x equals 0 plus h. So k into, in place of x I am putting minus h, because 0 minus h is minus h only. So minus h whole square minus 2 into minus h. On right hand side we have this cos 0 plus h is h only. So cos h. Here we have k, this is h square minus 2h. So plus 2h actually. So even if you take h outside with k, or let it be inside h, it's eventually, if h is tending to 0, this is going to be 0. On right hand side cos h, see left hand side I told you h is 0. So anything you multiply with 0 you get 0. But right hand side when you apply h as 0, cos 0 is 1. So the left hand limit and right hand limit, they are not equal. So when the LHL and RHL are not equal, there is no question about the continuity because it is discontinuous, right? So this function, because find the value of constant k for this to be continuous, but it is not continuous. When it is not continuous, so if you try that direct you can apply this direct limit here also, but you can try this, you won't get the answer. That's why it has to be done like this. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. Okay, so same thing we have to do here is left hand limit, right hand limit, and then just equate it and try to find out the value of k here, right? So this is LHL and RHL. LHL I am writing here, RHL here, and this has to be found out or computed at x equals pi. The point of contention, or you can say the continuity check, is x equals pi. So when you go a bit backwards, you have to use kx plus 1 because it is x less than 0. When it is x greater than pi, then you will use cos x. Less than kx plus 1, write cos x. So x is pi minus h you are going to use on the left hand side. X is pi plus h you are going to use in the right hand side. So k in place of x I am writing pi minus h plus 1. On right we are going to use this pi plus h. So cos pi plus h. Now cos 180 plus theta, either you use h equals 0, it is going to be cos pi. Cos 180 is minus 1. Or you can say cos pi plus theta is minus cos this value. Or you can simply say cos 0 is 1, cos 180 degree is minus 1. So eventually it is going to come as negative 1. This is the right hand side. Cos pi is minus 1. What about the left hand side? It is k into pi minus h plus 1. You can have h as 0. Either you can open it k pi minus kh plus 1. It is going to be this is going to be 0. So k pi plus 1. Now k plus pi plus 1 has to be equated to negative 1 because LHL is equal to RHL. So k pi plus 1 is equal to negative 1, 1 goes there. So k pi is negative 2, k is equal to negative 2 by pi, right? This is your answer. In each of the following, so these are all same kind of question. One of it we are going to do a different way, but here we have x equals 5, so we have to check at x equals 5. And if you go a bit backwards, x is less than 5, you are going to use kx plus 1. When you move a bit further, you have to use 3x minus 5, and x equals 5 is the point of continuity check. So x will be equal to 5 minus h on the left hand side, x will be equal to 5 plus h on the right hand side. So let us apply this. We'll find out the limit and we'll equate it. So k into, in place of x, write pi 5 minus h plus 1, and here 3, in place of x write 5 plus h minus 5. It is 5k minus kh plus 1. Here you have 5 is 15 plus 3h minus 5. Now you can apply the limit here. Limit, what is limit? Limit h tends to, see, it's h tends to 0 because we have already used x as 5 minus h. This cancel these out, 5k plus 1, here also cancel this out, 15 minus 5 is 10. So left hand limit, right hand limit, you have to equate. 5k plus 1 equals 10, and you get 1 here. So 5k is equal to 10 minus 1, that is 9. K is equal to 9 by 5. This is your answer. Now this one also same way. In each of the following, find the value of the constant k so that the given function is continuous at the indicated point. So you don't need to go through that LHL and RHL. Why? Because we can see that x square minus 25 can be written as x square minus 5 square, and x minus 5 x plus 5, that is going to be cancelled. X minus 5 gets cancelled. So I will directly do it using final limit rather than going for those left LHL and RHL. So limit x tends to, see, directly apply limit x tends to 5 here. You have x square minus 25 divided by x minus 5. So you have this x minus 5, x plus 5, because 25 can be written as 5 square. X square minus 5 square is x minus 5 into x plus 5. Divided by x minus 5, you can just cancel this x minus 5 and x plus 5 will remain. This x plus 5, apply the limit, x tends to 5, it is going to be 5 plus 5 is 10. Now this has to be equated to k. So what is this? Left is 10 and you can equate it with, because value of function at 5 is k. So k is 5, k is 10. This is your answer. Now let us check this at 1. It is kx square 4. Now LHL and RHL you can do, but I think that direct application of the limit can also give you this solution, because k into 1 square, k is directly 4, I can see that. But x equals 1, let us go the actual way. X is equal to 1 kx square. If you go forward, it is kx square. You move backward, it is going to be 4. So how do we apply limit at 4? Because it is a constant value. You can apply only the limit when we have certain x. You can apply x as 0 minus h or 0 plus h, then you can move forward. But this is already a constant. So just apply the limit x tends to 1. It will be k into 1 square, that is k. And since we have to equate it with the left hand limit with the right hand limit, k is equal to 4. Directly you can do this. But in order to show the examiner that I have already checked left hand limit and right hand limit, and then we have equated, and that's how k has come as 4, that you can also do. So basically what I'm trying to insist here is that while you are solving, you have to go through that whole procedure of k, LHL and RHL. But directly if you see that the answer comes like that and there is no untoward number which is going to come if you apply the limit, because the limit is only applied when you don't get a proper answer. The answer is 0 by 0 or infinity by infinity, like that. But here there is no problem. Even if you apply the limit, it is going to be same, k into 0 plus h, this 1 plus h square, 1 square plus b, a square plus b square plus 2ab, h is eventually 0, so it is k square, k into 1 square only. It is going to be equal to 4 because 4 is a constant, we don't have any x here. In each of the following, find the value of the constant k so that the given function is continuous. K into x square plus 2 here and 3x plus 1. So x as 0, it is kx square plus 2. If you go behind or backwards, it is kx square plus 2. If you move forward, it is going to be 3x plus 1. So x is going to be equal to 0 minus h here, 0 plus h on the right hand limit. So k into, I am writing minus h in this place, minus h square plus 2. Here we are going to write 3 into 0 plus h is h only, plus 1. So this is, you can apply limit here only, it's not going to affect anything. When we apply the limit h tends to 0, both way I am applying the limit. So this is going to be both way, okay. So this is 0, so twice k it is. Here 0, so you get 1, 2k is 1, k is 1 by 2. This is your final answer.